Hi everyone, welcome to new series which is on screw gauge. In the previous series we have learned about the vernier calipers, which is a device used to measure the lengths ranging from 1/10 of a millimeter to 1/100th of a millimeter. We felt like it is a precise instrument. Now the instrument that we are going to see, the screw gauge, is much more precise compared to vernier calipers because it measures the lengths ranging from 1/100th of a millimeter to 1,000th of a millimeter, and that is the reason it is also called micrometer screw gauge. Okay, in this series we will learn the principle of the screw gauge, its structure, zero errors, okay, and then the measurement procedure along with practically measuring the lengths using the screw gauge, and finally we will also solve few problems from previous JEE papers. Now look at the screen. Okay, you can see a cartoon image. So you can see there is a bottle and then a screw gauge, and they are talking to each other. The bottle says, we both work on the same principle, but our purposes are different. So you just observe the figure carefully and figure out what is the common in both of them. Yes. So if you want to open the bottle, that means you need to rotate the cap of the bottle in the anti-clockwise direction. Okay, when you rotate the cap of the bottle, so it rotates as well as it moves in the upward direction. Okay, it is because of the threads on the bottle as well as inside the cap. Now the same thing happens in the case of a screw gauge. So if you rotate the handle of the screw gauge in the anti-clockwise direction, then the cylindrical part that you see here, it moves up. Now, if you rotate both the cap of the bottle as well as the handle of the screw gauge in the clockwise direction, then both the things will move down. Therefore, the common principle for both of them is the rotational motion is being converted into the linear motion. So this is the working principle of the cap of the bottle and the screw gauge. And this is exactly similar to that of the way a screw moves inside a nut. So therefore, the screw gauge works on the principle of a screw that is moving in a nut. We just look at the nut and screw. That is how a screw moves inside a nut, and also we define pitch for the screw nut case. So here there is a nut and then in which a screw is inserted. This part is the head of the screw. Now if you rotate the head of the screw in the clockwise direction, then the screw moves into the nut, that is towards the left side. Okay, now if it is rotated in the anti-clockwise direction, then the screw moves outside the nut, that is towards the right side. So this part is called the tip of the screw. If the head of the screw is making more rotations, then the displacement of the tip of the screw will be more. So therefore we can say that when a screw is rotated in a fixed nut, its axial movement, that is along a straight line, is directly proportional to the number of rotations. Now this leads to a concept called pitch. Here we know that if the number of rotations for the head of the screw is more, then the displacement of the tip of the screw is more. Now the question is, okay, what is the displacement in the tip of the screw for one complete rotation of the head of the screw? So that is called a pitch. So therefore the pitch can be defined as, okay, the distance of the tip of a screw moves forward or backward because it depends upon the type of rotation, whether it is a clockwise or anti-clockwise. So when the head of the screw makes one full turn, so if it is making one full turn either in the clockwise direction or in the anti-clockwise direction, then the tip of the screw will move either forward or backward. That displacement is called pitch. So now how can we use this simple movement of the screw inside a nut to measure the lengths more precisely? To understand this, we take a simple setup. Now you take a nut and screw system. So just say the pitch of the screw is 1 millimeter. In simple words, you can say that, okay, the distance between any two side-by-side threads is 1 millimeter. Now we take the simple setup, that is, you consider a L-shaped frame, which is usually made of some steel kind of material or some iron material. Now you fix the nut to this L-shaped frame, okay, by means of welding, and then you insert the screw inside the nut You rotate the screw until the tip of the screw comes in contact with the vertical part of the frame. Once it comes into contact, now you make the markings as shown in the figure on the horizontal part of the frame. We have the markings from 0 to 1, that is 1 centimeter completely. And then the entire 1 centimeter is divided into 10 parts. That means each part is of 1 millimeter. Okay, the numbers shown here, okay, they are the millimeters. That is 1 millimeter, 2 millimeter, 3 millimeter, like that. Now you make an arrow mark on the head such that it is exactly coinciding with the 0 line of the scale on the vertical part. Now after one full rotation, now the arrow mark, okay, it completes one complete rotation. That means it will come back to the initial position. But if you see linearly, it will be having a displacement of 1 millimeter. Therefore, the displacement of the tip from the vertical part, it is also 1 millimeter. So now you make one more rotation in anti-clockwise direction. Then, okay, the gap created at the tip, that is 2 millimeter with the vertical part. Now you just reverse the rotation. That means you make 2 complete rotations in clockwise direction. Then the entire screw will go back to the initial position. And the arrow mark on the head, it coincides with the 0 again. Okay, if the head of the screw is divided into 2 parts, that means you make 2 arrow marks exactly on the opposite sides. One is coinciding with the 0 line, the other one is on the top. Okay. So therefore, this entire head of the screw is divided into 2 parts. We just say 0 and 1, that is 0 to 1, one half of the circular part, and then 1 to 0 is the second half of the circular part. So if you rotate the head through halfway, that means it completes half of the rotation. That means the 1 is coming to the 0 position, and then the 0 is going to the 1's position. So now here at this point, the 1 is exactly at half of the 1 millimeter. That is, if you draw a line, okay, that is exactly denoting half millimeter. Therefore, the gap created at the tip will be half millimeter. Now you go back to the initial position. So now instead of 2 parts, you divide the head into 4 parts. Just you draw 4 arrows. That is, just you mark it like 0, 1, 2, 3. So 0 to 1, the first 1/4 part, and 1 to 2, the second 1/4 part, 2 to 3, the third 1/4 part, and then 3 to 0, the fourth 1/4 part. So if you rotate the head of the screw such that the 1 is coinciding with the horizontal scale. So therefore, so it is covering a distance of 1/4 of the 1 millimeter. So if you draw a line that indicates 0.25 mm, okay, this gap will be 0.25 mm. Okay, now if you rotate the head of the screw further such that the second 1/4 part is covered, that is, the second arrow is coming to the bottom. So it is coinciding with the horizontal scale. So therefore, the displacement covered will be half millimeter. The gap created at the tip will be half millimeter. So if you rotate such that the third 1/4 is covered, that is, the third arrow is coming to the bottom line. Therefore, the distance covered here is 3/4 of the millimeter. The gap created at the bottom will be 0.75 millimeter. So now you rotate further such that the fourth 1/4 part is covered. Therefore, the arrow that is denoted by 0 is coming back to its original position. That will be exactly coinciding with the 1 mm line. Therefore, the gap created at the tip will be 1 mm. So here, the simple rotation of the head of the screw is converted into linear motion, and that linear motion is used for dividing the 1 millimeter into 4 parts. So now go back to the initial position again. Now instead of 4 parts, now you take the case of a screw where the head is marked with 100 parts that are equally spaced. So in this case, if the head of the screw is rotated such that 10 parts are covered, okay, so in that case, the gap created at the tip will be 1/10 of the 1 millimeter. Now, if 90 parts are covered, okay, therefore the gap created at the tip will be 0.9 mm. So if we are rotating the head of the screw such that only one part is covered, so therefore the gap of 1/100th of a 1 millimeter is created at the tip of the screw. So here, this is the least count that can be measured by using this simple setup. Okay, for the given screw gauge, if you don't know the pitch, Then you use the formula, that is distance covered by the tip of the screw for n rotations divided by the number of rotations. If the head of the screw is having n divisions, then you divide the pitch of the given screw gauge with the n number of divisions. That gives the least count of the screw gauge.